Hello, and welcome to an introduction to manufacturing. In this series of lessons, we will introduce you to common manufacturing processes, identify common manufacturing materials, and discuss recent technological advances that are shaping the future of making. Think about an item you have recently purchased. Did you stop to wonder about how long it took to make? How many hands have contributed to its production, or the types of materials and processes that went into making that item? Chances are you really never gave much thought to these questions, but pretty much everything you have ever bought has been manufactured in some form or another. Manufacturing is simply the action of converting raw materials into finished goods through a variety of processes involving human labor, tools, machinery, and chemical processes. Typically known as large-scale manufacturing, this allows for the mass production of goods using assembly line processes and technologies as its core assets. But this wasn't always the case. People have been making things since the dawn of time, and that has evolved from local artisans and groups hand-making specialty items one item at a time. We have seen great strides in advances in technologies, such as the printing press, utilizing steam power for mechanization, to harnessing of electrical energy and the assembly line popularized by Henry Ford in the early 20th century. More recently, in the 1960s, electronics and computers advanced automation and allowed manufacturers to produce more with less input from human operators, freeing up manpower from dangerous, repetitive tasks to do more specialized and creative endeavors. Now we are in the era of Industry 4.0. We are now using smart technologies such as sensors and the Internet of Things, also known as IoT, as well as artificial intelligence and machine learning integrated into machines and factories to make manufacturing more efficient. These cyber-physical systems allow companies to monitor all aspects of their factories and collect, but more importantly, analyze vast amounts of data in order to run their operations with little to no downtime, waste less, and produce more efficiently. A new trend in manufacturing is steering away from mega factories that often produce a single item and creating smaller, smart facilities that are able to produce more efficiently, but which are also more agile in their production capabilities. We all saw how supply chains were disrupted during the onset of the global pandemic, and large factories were forced to shut down and overseas supplies were not able to get their products to American markets. While micro factories were forced to shut down as well, they were able to open up faster due to smaller workforces and their highly automated processes requiring less in-person time than a traditional factory. Being agile in their production capabilities allowed them to adjust their output to demands in local markets. Microfactories are often locally based and provide solutions to local businesses that would otherwise have difficulty working with large-scale manufacturers. Likewise, microfactories produce for local markets to minimize shipping and other associated costs and provide jobs for the community. They allow for personalization and customization of parts that are not feasible with large-scale manufacturers. Because they are highly optimized, they require a smaller footprint and can be retrofit into pre-existing buildings without the need to build out entire giant warehouses, permits, and construction costs that go along with mega factories. They often use less electricity and are also modular so they can be reconfigured to meet production needs. In the same vein as microfactories, fab labs, also known as fabrication laboratories, are equipped to handle a variety of needs and services for the community. Fab Lab El Paso, for example, has a number of tools and digital fabrication machines that allow us to make almost anything. An overarching goal of the Fab Lab network, which is similar to the microfactories, is to provide resources for local economies to assist in producing their own goods, which eases the burden on transportation systems and allows us to meet supply chain demands so catastrophic events like the pandemic can be alleviated locally. In this image, you could see some of our early prototypes of PPE as we switched gears from our normal operations to filling the local community's needs for protective equipment during the onset of the pandemic. Throughout the Nurse Innovator series, we will introduce you to some of our more popular digital fabrication equipment and how you can get started thinking of designing products that could be prototyped here at the lab. Positioned on the world's largest binational borderplex, El Paso and Ciudad Juarez are home to a wide range of more traditional manufacturing industries, including automotive, electrical and semiconductors, food production, construction materials, textiles, and even more important for this series, medical equipment. Locally, over 30 factories and a workforce of over 40,000 people contribute to the medical device industry in the borderlands. Capable of producing a wide range of products and services, the region is well suited to provide a full service from design and prototyping to finished products ready to ship. Our strategic location along the border is extremely active due to the ability to take advantage of deferred duties, reduced import costs, logistical benefits like access to highways, railroads, and international airports, and many more regional factors which all combine to produce over $70 billion of border trade annually. While modern manufacturing has evolved and now requires a broader set of skills, including product design, engineering, international distribution, technology maintenance and information security, material science, and finance, you do not have to specialize in every single aspect to get a product to market. However, a broad knowledge of the process is extremely valuable, and you can save many mistakes and headaches as you go on your journey to become a nurse innovator. Just as the iterative design process is circular, the manufacturing process has 5 major parts to consider, and each one can affect the others. As you go through the early phases of planning and design, you will want to keep in mind your end goal and how your product will be produced, as this will influence all the other factors. The first is form, or the physical geometry of the design. The form may limit manufacturing options, and part optimization may be required to allow for certain processes and to make the product economically feasible to produce. Determining the production process early on can save you a lot of redesign time later on in the process. Next is volume and cost. Higher quality machines and tools tend to cost a lot upfront, but they do last longer and have higher quality finishes. Similarly, choosing lesser quality tools may be cheap upfront, but in the long run might affect production and quality. For example, a lot of people are using 3D printed molds for short-run productions, and while the prints themselves are inexpensive, they only last for a couple hundred parts at most. On the other hand, you could spend a lot more money upfront to create a CNC machined master mold. The quality and durability will be higher, and you can make many more parts. Depending on the total volume or quantity of parts in a production run, the fabrication cost per part typically decreases with larger quantities. Depending on how many parts you are producing and how those parts are produced affects the next factor, lead time. Lead time determines how quickly finished products can be produced. Lead times can vary depending on the process, but don't be surprised if some processes take upwards of 4 months to set up machines, tool, and deliver. This is definitely something to consider, especially when you get further into the design process. Lastly, materials. Decisions must be made in terms of cost, aesthetics, and the right material for your product. If you are making a medical part that is going to be in direct contact with a person, for example, there are many laws that need to be understood and considered, and production facilities must be certified to produce those types of materials. Likewise, depending on the chosen material, this may determine the manufacturing methods. This also may determine design elements of the physical form, and the manufacturing process continues until your product is ready for market. Now that you have a basic overview of the process, next we will take a look into some common materials and manufacturing methods.